we zoom in, we can see that this LCD screen has a lot of wires connected. So starting from the left, we've got one going to ground, we've got one going to power. This one goes to the center, the read, the wiper of a potentiometer, which itself goes to power and ground. We'll see when we turn that on that that's what kind of brings it into, I don't want to say focus, into contrast correctly. There's another ground here, and another one at the end. The important ones that have to go in just the right spot as well are all of these that go to the board. So this one goes to 6, to 7. We skip a couple, so skip, 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 skip 4, then to 8, 9, 10, 11. This one goes through a resistor to ground because that is the backlight LED of your LCD screen, and then a final ground wire. So that takes up a lot of pins of your digital side of your Arduino board here. It doesn't have to go in those exact pins. It could be a different set of 6, but this is how it's set up to work with the code that I have ready, which I will show you now. So this is a very simple example. If we look at what it says, we can see right up at the top right here, the first important thing we do is include that LCD library or the liquid crystal.h file. And then here, this line is where I'm telling the Arduino what pins I will be connecting my LCD with. Okay, so you can see just like it is over here, 6 through 11, here we are 6 through 11. So if I decided that I wanted this purple one to go into pin 12 instead, I have to update it in the code right here, or it just won't work, right? This is our map that tells the Arduino where to send the signals. So if we don't have the pins out here matching the pins in the code, it's not going to work. Okay, in our setup section, we have lcd.begin. That's letting it know that we are going to start using that LCD screen. And this type of LCD screen is a 16 by 2. So that's 16 characters long. Total of 2 characters or lines high. So I can only print things that fit in that. So 2 lines high, 16 characters long. And the example here is going to print out seconds running on that top line. In our loop section, we're doing just a few things right now. We're going to set the cursor. That means we're telling it where we want to print. Okay, so this one is saying set the cursor to column 0, line 1. So column 0, that's going to be all the way at the left. Line 1, that's going to be the bottom because we start out counting by zeros, right? So line 0 is the top, line 1 is the bottom. And here we've seen millis before. We're going to use lcd.print, and we'll just be able to see how long the program has been running and a little bit of a delay to slow things down so that it can print to the screen in time. I'm going to start the simulation. And we can see there's that seconds running text on the top row, and you can see those millis divided by 1,000, so approximately seconds counting up on the bottom row. So important things to keep in mind when you're wiring up an LCD is that those 6 through 11 in this example, those really have to be in just the same spot. If you move one on your board, you have to change it in the code to match. Second, you do need this potentiometer. I'll show you what it looks like when we get it out of focus. This is a little more noticeable when we build it in the real world. You'll see that this helps you bring the text into contrast against the back. And then this guy, if we don't have this one here, the LED backlight doesn't work correctly, so we can't see the brightness behind the display. Again, a little bit easier to see when we build it in the real world. Okay, you should be ready to hook yours up and run this example and start a project. Thanks.